In this lesson, we're going to look at alkyl and halo side groups on various organic molecules. So we looked at alkanes, alkenes, and alkynes and the carbon backbone in an organic molecule. So we're going to start looking at different things that can be added on. So we don't always have a one long chain of carbons. Sometimes we have a branching off of carbons as well. And so when we have a branching off of carbons from our main chain, that is called an alkyl group. So alkane was our long chain of carbons where everything was a single bond, alkenes had a double bond, and alkynes had a triple bond. An alkyl group is a group that gets attached to part of that main chain. So it doesn't make the chain longer, there's a branching off somewhere. And so we essentially have one less hydrogen. So methane was CH4. And as a methyl group, so if we look at a carbon that needs to have 4 bonds, if one of those bonds is going to be to another group, and I'm going to use R to denote some other chain that is happening, then we can only have 3 different hydrogens. So that's what this removing an H from an alkane means. So one of the carbons has one less hydrogen, and that's where it would be attached onto the main chain. So the other attachment that we're going to look at today are different halogens. And so whether that is fluorine, chlorine, bromine, or iodine. And those, so for alkanes, we're going to get rid of the ane part and il in terms of the naming. So meth for one carbon and methyl for a CH through group added on. Eth for 2 carbons. So if we have a 2 carbon chain attachment to a longer chain, that is an ethyl group, and so on. So for our halogens, we take the first part, the fluor-chlor-brom iode, and then add an O on. So we get rid of the ene ending for fluorine, chlorine, bromine, iodine, and then we add an O. And so these are going to become part of the naming for our full compound. So the guide to naming our alkane is first, we are going to find the longest chain of continuous carbons that we can find. And then we are going to number those so that we have the lowest number getting to, and substituent here is referring to either that alkyl or halo group. So we want the lowest numbering possible there. And then we're going to give the location of each of those groups based on that numbering, and then we are going to write them in alphabetical order. So if I look at this molecule over here, I have 1, 2, 3, 4 carbons. I could also see it as 1, 2, 3, 4. Either way, we'll end up with the exact same name. So the longest chain here is 4 carbons, which makes it a butane. So all single bonds, which is why we have the ane. And then I'm going to number the chain. So we've got 1, 2, 3, 4. So if I had gone in reverse order 1, 2, 3, then my methyl group would have been off the third one. So shorter numbering, the smaller numbering for my substituent group is to number from here. And so off the second group, I have a 1 carbon, so meth. And then as a group, we have the il ending. So that methyl group is off the second carbon. So that's our third step, is to locate the side groups or substituents and then name them. So I have a methyl group off the second carbon attached to butane. So 2-methyl-butane is the name for this. So remember we looked at before that anytime we were in between numbers and words, we were going to use a dash. So 2-methyl-butane is this compound. Okay, so we've got another molecule here. So once again, we're going to look for the longest potential chain. So if I did 1, 2, 3, that ends there. So I can see the obvious 1, 2, 3, 4. That 1, 2, 3, 4 this way is no different than 1, 2, 3, 4. So I still have off the second and third carbon, whichever way I am counting. Off the third carbon, I have methyl groups there. So longest chain once again for step 1 is butane. And then we're going to number that chain. And once again, in this case, it doesn't matter which end we start from. So I've got 1, 2, 3, 4. And so off the second and third carbons, I have methyl groups. So this time, just like when we had 2 double bonds and we were going to say diene to say we had 2 of those, we're going to use that same prefix here for methyl groups. So we have 2 methyl groups. So instead of methyl, we're going to go with dimethyl. And then they are off the second and the third carbons. So I have a 2, 3 dimethyl butane. Okay, so here once again, we can look at a straight chain, but this would also give us the exact same. So numbering wise, or actually first here, we have 5 carbons, which makes it a pentane. And then we're going to number so that we have the lowest numbering. So if I do 1, 2, 3 off the second and third, if I do 1, 2, 3, 4 off the third and fourth. So numbering from this end is going to give me the lowest possible numbering. These clearly are shifted. So this is a chlorine and this is a methyl group. So we can't have it the way it was because this carbon has 1, 2 bonds already, and then 2 hydrogens makes 4. And then this one only had 1, 2, 3, so it needed one more thing. So shifting there. Okay, so off the second carbon, we have a methyl, and off the third carbon, we have a chloro. So chloro starts with C, methyl starts with M. So for our side groups, we are going to put them in alphabetical order. So the chloro comes first off the third carbon, then the methyl off the second, and then pentane. So I have 3 chloro, 2 methyl pentane. And so here with the number in the middle, I have the dash before and after happening there. Okay, so next example here. So I've got 1, 2, 3, 4, 5 carbons. Once again, I could count this way, 1, 2, 3, 4, 5, or 5, doesn't matter. Either way, the longest chain I can get is 5 carbons, and numbering is going to be the same for either way again. So if I do 1, 2, 3, 4, still off the second and fourth. So it doesn't matter in this case, it's symmetrical. So off the second and fourth carbons, I have methyl groups. So 2 methyl groups total. So off 2, 4 dimethyl pentane. Okay, so over here we've got 1, 2, 3, 4, 5, 6, 7. And if I started here, 1, 2, 3, 4, 5, 6, that's shorter. So our longest is from here. If I did 1, 2, 3, 4, 5, 6, 7, then I have 3, 5, 5. 1, 2, 3, 4, 5, 3, 3, 5. So if I didn't have either the methyl or one of the chlorines here, then the 3 and 5 would be the same, but because I have 3 groups total, if I number from this end, then I get 3, 3, 5, which is lower numbering than 3, 5, 5. So there is my numbering. So off the third carbon, there is a methyl and a chloro group, and off the fifth carbon, there's a chloro. So I've got chloro and methyl. Chloro comes first because C comes before M alphabetically. And then I have 2 chlorines, so dichloro, and off the third and fifth. So I have a 3, 5 dichloro, 3 methyl, and I think that is 7, yeah, heptane. So 3,5-dichloro 3-methyl-heptane. Oops. Okay, draw 3-bromo 1-chloro-butane. So here I'm going to work from the opposite end. I'm going to work from over here. So I have a butane. But means 4 carbons. Ane means they're all single bonds. So I'm going to start with that longest chain, the 4 carbon atoms. So I'm going to draw those in, all single bonds. Then the next thing I'm going to do is number and add the substituent. So here you can always start from left to right when you're numbering. So 1, 2, 3, 4. And off the first carbon, we have a chlorine. And off the third carbon, we have a bromine. So it doesn't really matter here which end you start from. It also doesn't matter where you are placing that. So this bromine could have been underneath. The chlorine can be off to the side, underneath, or above. There is no difference at the moment in where that goes. Later on, we will talk about how we can determine what is most likely to occur. So there's our numbering. And then we're just going to add in hydrogens to complete so that every single carbon has 4 bonds. So this carbon right now has 2, so it needs 2 more hydrogens. This carbon has 2, and what's going on here? 1, 2, 3. So this should not be a 2. So this should be a 2 here. So this carbon has 1, 2 things it is bonded to, so it needs 2 hydrogens. This carbon has 1, 2, 3, so it only needs 1 hydrogen. And this carbon only has 1 bond, so it needs 3 hydrogens, so that it has 4 bonds total. Okay, so for alkenes and alkynes, the double and triple bond are going to take precedence for numbering. So the other thing too is when we come up with the name of the alkene or the alkane, our longest chain of carbons has to include the double or triple bond. So in this case, it may not be the longest continuous chain of carbons that you can find if the double or triple bond isn't within that. So it has to be the longest chain that includes the double or triple bond. And then you're going to number it so that just that double or triple bond has the lowest numbering. So this time we're not going to care about the substituents that are added in terms of numbering. We will do that. We will do our numbering based on having the lowest number for our double or triple bond, and then we will use those numbers for the locations of any substituents we have. Okay, so I thought I had these. Oh, no, different slide. Okay, so here I have 1, 2, 3, 4, or 1, 2, 3, 4. Doesn't matter. All of them include that carbon. Now here, 1, 2, 1, 2. So either way, the double bond is off the second carbon, no matter which direction I count from. So in this case, because it doesn't matter for the double bond is going to be off the second carbon either way. So we have a but2-ene regardless because our double bond is off of that. So in that case, we are going to look to our substituent and we're going to number from this direction to give this the lowest number possible. Once again, only because our double bond is in a location where the numbering is the same from either end. So in that case, we're going to make our methyl group the lowest. So that gives us the same as that for the double bond, whoops, but not for the methyl group. So off the second carbon, we have a methyl group and we have a but2-ene. So 2-methyl-but2-ene. For here we have 1, 2, 3, 4, 5. And if I number from this direction, the third carbon has the double bond. If I number from this direction, the second one has the double bond. So I'm going to number from the right. And so we've got a 1, 2, 3, 4, 5, so pent. And then off of the second carbon, I have a double bond, so pent 2-ene. And then off the third carbon, there's a methyl. So we're going to start with that 3-methyl and then pent 2-ene. So here I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Either way, looks like that is our longest. So we have to include this part in our longest chain because of the double bond. So if we number from left to right, 1, 2 off the third carbon is the double bond. From right to left, 1, 2 off the second. So that's going to be our lowest numbering. So 5 is pent, and off the second we have an ene. So same part as this, pent 2-ene. And then off the third carbon, we have 2 carbons here, which is F. So we have an ethyl group. So 3-ethyl pent 2-ene.